Okay, so I can only zoom out so far. I can't zoom out and you actually see the entire triangle. And because I'm having to use this thing, it jumps a little bit, but and it can be kind of annoying. But this is my right angle up here, and then this over here is the long skinny side, right? And so you're going to take one of your colors, it doesn't matter which one, and we're going to label this B. We have to label our angles on the inside because we can't write them on the outside because we can't write on the outside of our triangle. Yes, this is the right angle, which is supposed to be at the top for you. Bottom left over here, this is A. I still have the same color in my hand. And then the far right down over here is angle C. Okay, so we have triangle ABC. Now, it is important that you pay attention to the next few steps so that you don't do these wrong, because then that's going to cause you to have extra creases that you don't want or need. So what we're going to do, we have triangle ABC, right? We are going to find the midpoint of each side of the triangle. So I'm going to start with the midpoint of AB. In order to find that, I'm going to take point A, I'm going to place it on top of point B so that the two, and I know it's hard to see because of the lighting, but those are right on. I have not creased anything. Do not crease anything just yet. You're going to follow along. The side should just line up right with itself, and you're just going to pinch it right there. Do not crease it all the way across, or you will regret it because then other stuff won't work out too well for you. So I'm just pinching it right there after I've put A on top of B so that I can find the midpoint of the side. Does that make sense to you? So you have this tiny little crease there, which you may not be able to see mine, again, because of the lighting. But wherever that little crease is, you're going to put a point there, and you're going to label that point D. Huh? Oh, I changed colors, but it doesn't really matter either way. D. Okay. And then I'm going to do the same thing over here for line segment BC. Can't really even see my C over here. I'm going to take C. I'm going to place it on top of B. Once again, I am not creasing this all the way across. I'm just pinching it right there just so I can find the middle of the side. I'm using the same color I did for D. And then I'm going to label that point E. E. And then you are going to take C over to A so that you can do the bottom. Same thing, little tiny pinch down there, and then make this point F. Okay. So my midpoints are points D, E, and F. Everybody understand the instructions there? Yes. All right, so then, since point D is the midpoint of line segment AB, I need to label that. So how do I label the side of the triangle to show that point D is the midpoint? Okay, so line segment AD would be congruent to DB, right? So I'm going to put the little hash mark. So I'm going to put one here to show that those pieces are congruent. Okay. And then same thing for over here, since E is the midpoint, but I can't put one because I put one on the other. So I'm going to put 2 here and 2 here. And then I'm going to do the same thing down at the bottom for AF and FC. 3 there, 3 there. Okay? So now D, E, and F are all 3 midpoints of the sides of the triangle, and the triangle is labeled accordingly. Everybody with me? Okay. So now you're going to take a ruler, which there should be rulers on your table, and you're going to connect points D, E, and F with a ruler, not freehand. It is going to make a triangle because we are connecting 3 points. I'm using the same color that I labeled D, E, and F in. Y'all can do whatever colors you want. It doesn't matter. It's going to be better for you if you change them up a little bit so you can kind of tell what's what. Yeah, some random color. It doesn't matter. Okay. I really wish I don't know why this lighting all of a sudden is so bad. I think it's because I'm using the, there we go, maybe that's a little bit better. It's not great, but I think it might be better. Well, it was fine. I wasn't using this visualizer thing in the other classes because I have to use that when I record, so I wasn't having that issue. But okay, so are we all good? Everybody with me? Are we still drawing line segments? Okay, so each one of these line segments was created by connecting midpoints of the sides of a triangle. And so that has a special name. The segment that's created when you join two midpoints of, or the midpoints of two sides of a triangle is called a midsegment. And so we're going to write our definitions right on our little triangles here. So I'm going to write this on DE. So the definition is, yeah, you can read that. A midsegment of a triangle connects the midpoints of two sides of a triangle, or of the triangle. Same thing. Okay? So that's what the midsegment is. So how many midsegments did we create? 3. Triangle is 3 of everything. 3 sides, 3 angles, 3 midsegments, 3 heights, 3 everything. A midsegment of a triangle connects the midpoints of two sides of a triangle. Or the triangle probably makes more sense. Okay. So now what we're going to do is we're going to take this and we are going to fold this triangle, even though I do have 3 midsegments. So DE, EF, and FD, all 3 of those are midsegments. They're just 3 different midsegments. We are going to fold the triangle on line segment DE. Okay? So in the end, I want the words on the inside, but we're going to fold it first with the words on the outside so you can actually see the segment. So when you fold it on that line segment, what's going to happen is point B should come over here and just barely touch that third side. Okay? If it is, mine's hanging over just a teeny tiny bit. If it hangs over just a tiny bit or doesn't quite make it just by a tiny bit, that's okay. If you're like way off, then something you're just not doing something right. But because of, if you didn't fold it exactly right or the line exactly right, it might not be perfect. Okay? Then once you got that and it's lined up, then you can fold it. You can just reverse the fold so it's on the inside. It's just easier to fold it with on the outside first so you can see the line. Okay. You were supposed to fold it with the words on the outside, and you were folding on line segment DE with the words on the outside, and then you just reverse it so that the words are on the inside. Okay? Everybody good? Okay, so this is point B, right? And we folded point B down, but now I can't see that it's labeled point B because it's on the inside. So we're going to write point B on the outside as well. Okay. So that way I can still tell it's point B. Now, I am not doing the same thing on the other 2 midsegments. I've done it once. Now I'm going to take point A and I'm going to fold it in so it touches point B, and then that bottom side to just fold on top of itself, like so. Okay, so you take A, you're folding it in until it touches B, and it should just cover up all that space right there. And then we're going to label A on the outside. I'm doing the same color I originally labeled A, B, and C in. Yeah, and then you can crease that. Yes, crease that one all the way. And then do the same thing for C. Bring C into B, and then crease that. Okay. Okay, and there might be, I have a few gaps here, but I think it's because I'm just trying to draw my line really straight, but it's close enough. Your gap should not be that big. Let me see what you have going on here. Okay, because this is not straight. You have to fold on this line segment. You just made up a line segment. That doesn't work. It has to be on that line segment right there. Like that. Make sense? Okay, so then fix that one. Okay, okay, good. So now it should be labeled A, B, and C. Now this is one of a few different types of ways to prove that the three angles of a triangle make 180 degrees. Because aren't A, B, and C just the three angles of the triangle? When you put them down like this, you see how the three of them together make 180 degrees? Bam, there's one of the proofs right there. Okay, so now when it's all folded up like this figure that you get, what does this figure look like it is? A rectangle, okay? And I said look like it is because we don't necessarily know for sure that it's a rectangle, but it sure looks like one, right? So let's see if we can at least figure out if maybe we know we're on the right track to a rectangle. If I take A and I'm going to open it back up, okay? This triangle that I have right here, triangle ADB, what kind of triangle is that? It is isosceles, because look, this is DB, right? And isn't DB the same as AD? So when I fold it down like this, these two are still congruent, so I have an isosceles triangle here. You see that? Okay. So this is an isosceles triangle. When I folded A to B like this crease that I got, didn't it go right through the midpoint? Yes. So it went right through the midpoint. That means that the bottom down here got bisected, right? And since it went through the midpoint and goes through the vertex, how else is this crease related to the bottom of this triangle? It's perpendicular. This ends up being the perpendicular bisector. Okay? So since this is the perpendicular bisector, that means that when I close this, is this for sure a right angle? Oh, yes, it is. So I've got a right angle right here. Now, if I open up C, the same thing happens, right? This is an isosceles triangle. When I do this is the perpendicular bisector, so this is a right angle right here. Now, that still isn't enough to guarantee us that it's a rectangle. All that tells me is that these two pieces right here, or these two angles right here, are 90 degrees. Now, if I look at these two sides of the triangle, and then this third one being two lines cut by a transversal, what type of angle pair are these two right angles? Same side interior. So if these two angles right here are same side interior and they're supplementary, then are these two sides of my quadrilateral parallel? Yes. Okay, so I know that these are parallel and I know that these are right angles. It's kind of the best I can do right now. If that's all that is true, if that's all I had was exactly one pair of opposite sides parallel, what is that shape? When you have exactly one pair of opposite sides parallel. No, a rhombus is a parallelogram. Both pair of opposite sides are parallel. So is a rectangle. So is a square. It is a trapezoid. And the trapezoids are going to be the downfall of some of you. If you don't know the properties of a trapezoid, what one is, how to identify it, all that kind of stuff, you might want to go Google it because that seems to be, I don't know, rocket science for some people, but that is definitely old business. So exactly one pair of opposite sides parallel is a trapezoid. Now, this doesn't necessarily mean that it's exactly one pair of opposite sides parallel. That just means that's all I've got right now. Because we haven't talked about quadrilaterals yet and we haven't talked about some other things, I'm just going to go ahead and tell you that this is a rectangle. I mean, there's some other things that we could look at, but that's not what's really important right now. But this is a rectangle. We can at least get that those things were congruent. Or I'm sorry, those angles were 90 degrees. But this is a rectangle. So if this is a rectangle, that means all four angles are right angles. That also means that both pair of opposite sides are congruent. Okay, we all good with that? So we have this rectangle. When I open up A and C, I'm going to have to open mine up and turn it sideways so maybe you can see the whole thing. Then I get this shape here. What is this thing? This one is a trapezoid. Okay, since this is a trapezoid and DE is still parallel to AC. We good with that? Now, line segment DE is what part of my original triangle? What's it called? Line segment DE. It's a midsegment. Good. Line segment DE is a midsegment of the triangle. And notice how it is, the DE connects the midpoints of these two sides and it's parallel to this third side. That's not a coincidence. That happens every single time. Right now, we all have the exact same triangle, and they happen to be right triangles. The fact that it's a right triangle is irrelevant. The fact that they're the same is irrelevant. We could all have different triangles, and ours might look different at this point, but we would still have a trapezoid here. We just have different looking trapezoids because the mid-segment is always parallel to the third side. Okay? Now, let's talk about the length. How do you think the length of DE is related to the length of AC? What do you think would be true about the length of it? It's double, okay? Do you have a reason that you could back that up with, or even if it's not a fancy theorem or something, like what makes you think it's double? It's okay, you don't have to give me theorems and stuff. Uh-huh. You're trying. I know. It's okay. All right. So let's think of it this way. You're on the right track. I have this, and the bottom is completely covered up, right? So when I open this up, remember, this is the midpoint of this base of this isosceles triangle right here, right? So right now, if I look at just this isosceles triangle, when I do this, aren't I cutting that length in half? And right here with this isosceles triangle, whatever this length is, when I do this, am I cutting it in half? Which means when it covers it up exactly, when I open it up, doesn't the bottom get doubled? So right now, the base of this rectangle, we double it to get the base of the trapezoid. Does that make sense to you? So that means that the bottom, the length of AC, is twice as much as DE. So DE is related how to AC? It is what? Half. If AC is twice as much as DE, then DE is half as much as AC. Does that make sense? Okay, because you got to understand that relationship, but what we're talking about here is mid-segment. So everything's related to the mid-segment. The mid-segment isn't twice as much as the side. The mid-segment is half the length of the side. You with me on that? So it's the right concept. You just got to make sure you're saying it in the right direction so that you're not getting yourself confused. So right here, we have this original triangle. We have this mid-segment that is line segment DE. It is parallel to this third side, and it is half its length every single time. Okay? Does that make sense to you? Now let's go over here, and we're going to label some of that stuff. Let's look at DE. If DE is half the length of AC, then what is DE congruent to? Think about that. If DE is half the length of AC, then what is DE congruent to? Braden. FC and FA, right? Isn't F the midpoint? So isn't AF half of AC? And isn't FC half of AC? And DE is half of AC, so all three of these segments here have to be congruent to each other. Does that make sense to you? So I don't know what the length is, but I do know it's the same as AF, so I can put 3 little marks on it. So then FE, what is FE congruent to? No, FE is not congruent to EC. FE is a mid-segment. It is related to the third side, which side is it related to? AB. The side that it cannot be parallel to EC. FE is parallel to AB. So FE is congruent to what? AD and DB. Good. DF is also a mid-segment. It is parallel to this side, and so it is congruent to BE and EC because it's half of that length. Okay. Everybody good with that so far? All right, so now let's label some parallel stuff because we've said it, we just need to make sure that we show it. DE is parallel to AC. Now, when we show that things are parallel, we use the little arrows. But if I use an open arrow on part of this, it's going to look like it's just a hash mark, and I don't want that to happen. So instead, I'm going to use the closed arrows, which makes them look like little triangles. So I'm going to show that DE is parallel to AC. So I'm going to put one arrow on DE, which is going to look like a little shaded in triangle, but that's an arrow because I can only put half of it down here because I can't get on the outside of the triangle. So that means that DE is parallel to AC. Then on FE, I'm going to put 2 of them. So FE is parallel to AB. And then I need to show that DF is parallel to BC. Okay. Everybody okay with all that? That make sense? Understand the labels and everything? Okay, so what we came up with, now I just gave you a triangle, which again could just be any random triangle, and we could do all these folds and come up with all this all by ourselves. And what we've come up with is the mid-segment theorem. This is not a coincidence. It's going to happen every single time like this. And so the mid-segment theorem we're going to write over here in this triangle. As soon as everybody's done, I'll label in. Yeah, it doesn't matter what kind of triangle it is at all. That's why we didn't even mark that that's a right angle, because that's irrelevant. Okay, so over here in this left-hand triangle, oops, let me zoom in a little bit. We're going to write the mid-segment theorem. This is what the mid-segment theorem says. Okay. It says a mid-segment of a triangle is parallel to the third side and half its length. Okay? Mid-segment of a triangle is parallel to the third side and half its length every single time. Just turn it off. All right, so then on the far right-hand triangle over here, we're going to write what all that tells us. That tells us that the length of line segment DE is equal to half the length of what? AC. DE is half the length of AC. And you'll have to look at your own triangle because I can't do both at the same time. That also means that line segment DE has to be parallel to line segment AC. And then line segment FE is equal to half the length of what? You know, Carla, I wouldn't have to stop and wait, and you could get this done a whole lot faster if you weren't trying to braid your hair while we're doing this. All right, so FE is half the length of what now? AB. And then line segment FE is parallel to AB. And then DF, the length of DF is equal to half the length of what? BC, good. Which means that line segment DF is parallel to line segment BC. Now, that tells me other stuff, too, that, well, I mean, we're not going to write down everything we can figure out, because I also know that the length of DE equals the length of AF and all that kind of stuff. But this is what we directly get from the theorem. Okay. Everybody good so far? All right, so now, how many total triangles do I have here? 5. Okay, I have 5 total triangles. I have 4 little ones and 1 big one. So of the 4 little ones, what do you think is probably true about those? Close. They're all congruent. They look like they're probably congruent, right? Do we have enough information to actually say that all 4 little triangles are congruent to each other at this point? Yes, based on what? The sides. Okay, so I've got all 3 sets of sides congruent in all 4 triangles. Is that enough to say triangles are congruent? No. What's the only way you can say triangles are congruent? The angles. You have to have all three sets of sides and all three sets of angles. We don't have anything about any of the angles at this point, right? So if I did, now, do we have all three sets of sides congruent in all of them? Yes, we do. So we just have to get the angle stuff going. So let's go and label some angles and see what we can figure out. So on A, I'm going to put 1 little arc. On B, I'm going to put 2. And on C, I'm going to put 3, just so that I can show that those are different. Okay? So 1 on A, 2 on B, 3 on C. And then I want you to look at angle D. What do you think angle D is congruent to? Okay, so I love how y'all are all trying to answer my question when my question makes absolutely no sense. When I say angle D, how do you even know what I'm talking about? You don't? Because this could be angle D, or this could be angle D, or this could be angle D, or that could be angle D, or that could be angle D, or the whole thing, or maybe this around to here. You don't know, right? Me calling it angle D doesn't even make any sense, and y'all have all decided you think you know what it is, right? Do you see why you can't name it with one letter? Yeah, every single class is falling for that today. They're all arguing over what the right answer is. You're probably not even talking about the same angle, right? You probably have different answers because you're looking at different things. Okay, so I can't say angle D. That's not enough information for you to be able to tell. That doesn't even make any sense. Now, can I call this just angle B? Yeah, that's fine. Okay, so the angle I really want you looking at is angle I'm sorry, no it's not. I want you looking at BDE. Angle BDE. And before you tell me what you think it's congruent to, you need to be able to back that up with a reason. Okay, on. Very, very good. Okay, so these DBE, so it's this angle right here that I'm looking at. This segment is congruent to this, I'm sorry, it's not. It's parallel to this side of the triangle. This would be my transversal, therefore these are corresponding angles. Does that make sense? Very good, perfect, thank you, On. Okay, so we all agree with that angle? So we got one angle down. Okay, so now I want you to look at angle BED. BED. Want to know what would it be congruent to, and how do you know? C, can you tell me why? Okay, he wants to say they're corresponding angles. If he was to actually say that, would he be right? Yes. You still want to say that? Yes. Yes, good. Okay. So again, we've got parallel sides. This is a transversal. These are corresponding angles here. That works. That totally works. Can somebody tell me a different reason why these would be congruent? There's nothing wrong with that one. There's just different ways to do things. Besides corresponding angles. Amy? No, not necessarily. Natalie, what were you going to say? So these two angles here, Jose? Okay, the midpoint doesn't really have anything to do with the angles, though. But, go ahead. But you don't know that yet. You don't know that before you say that the angles are congruent. But what happens when you have these two angles here are congruent to angles A and B in the big triangle, right? So then these angles have to be congruent because of the third angle theorem. Okay? So the third angle theorem works too. There's nothing wrong with corresponding. Clearly that's probably what all of you should have used, and that's fine, but that works too. Okay, good. Seriously, sweetheart, you better stop with the hair because this ain't beauty school. All right. Now let's look at angle ADF. ADF. What do you think angle ADF is congruent to and why? Go ahead. Okay, why? Good. Got corresponding angles again, right? This has to be congruent to B because these are corresponding angles. Here are your parallel lines and your transversal. That works. So then what about angle DFA? DFA. Angle C, good. Why? Third angle theorem. So it could be angle C because it's a third angle theorem, or it's also corresponding to C. That works too. Alrighty, so then what about FEC? It would have to be congruent to B because these are parallel. This is your transversal. Those are congruent. Okay. Which means this one has to be, hey, third angle theorem, right? We like that. We can use that. Third angle theorem. All right, so now I need to look at the inside here. What about angle EDF? EDF. Parker?
It's corresponding to angle C.
It's not corresponding to angle C.
I meant like it's congruent to angle C.
Okay, why?
Because DE and FC are parallel. And
DE and FC are parallel, okay. And how does...
they're equal sided.
Okay, but the parallel lines do not relate this directly to angle C at all. Because those aren't even made up of the same lines. Okay? Not saying it's not congruent to angle C, I'm just saying that reason does not hold water. On? Awesome, beautiful. So these are parallel. This is your transversal. And then these are alternate interior angles. These were corresponding, so that did come from angle C, but these are alternate interior angles. You see that with your parallel lines? Parallel lines in your transversal. Very good. Now, somebody earlier today said, well, I know it's congruent to angle C because of a linear pair, but I know it's not a pair, but you know, they're like trying to get the, so these three have to give you 180, right? But it's not a pair, so it was like there's not a good way to say it, but it does work that way too. Which means that this then has to have how many marks on it? 2. And we also have some alternate interior angle stuff. And then this has to be 1. Okay, so now do you have enough information to say that the triangles are congruent? Yes. Okay, so on the inside here, the middle, we're going to say triangle, we'll start with ADF is congruent to triangle. Okay, so I started with the bottom left. Let's go to this top one. This top little one would be what? Triangle, how would I have to name it? DBE, good. Which would have to be congruent to, and then we'll go to the bottom right. How would I have to name that one? FEC, good. Which is congruent to triangle. Now this middle one, what would the middle one have to be? Well, A corresponds to E in this triangle, so it would have to be EFD. So all those triangles are congruent by the definition of congruent triangles. In order to use that, I have to have all 3 sets of sides and all 3 sets of angles congruent. Oh, sorry, you can't even see my letters there. Everybody okay with all that? Any questions? All right, so then I want you to go to the top, in this top triangle up here, and we're going to write that triangle ABC, that is your original triangle. Then triangle EFD is created by the 3 midsegments, so this is called a midsegment triangle. Now, how are those 2 triangles related to each other? They're not congruent. What's that word? Do they have the same shape? Yes, so the angles are congruent, so they have the same shape, but they have a different size. It starts with an S. Same shape, different size. This little symbol, which is not, it's not right here because we're not doing logic, but draw that little symbol. Starts with an S in similar. Okay, yes. So that little squiggly here does not mean not, because this is not logic. The little squiggly means is similar to. Okay. So the four little triangles are all congruent to each other, but they're also all similar to the big one. Okay. All right, so now I want you to close this and write on the outside midsegments of triangles. And then I'm going to pass out the a little part that has the examples on it. So grab one of these so we can get through these examples real quick. Nope. Okay, so grab the little half sheet and let's look at this. So we're going to start by looking at what we have. We're going to look at the picture and think through what we have before we just start doing stuff, right? So is a line segment LM a midsegment? Is LM a midsegment? Yes, because it connects the midpoints of two sides of a triangle, right? Which means that LM is congruent to what? XN. It is congruent to XN because it's parallel to this side and half its length, right? So which means it's congruent to the little pieces. Is NM a midsegment? Yes, so it's congruent to one of these pieces here, right? So not only are they, half the length, but we also have some parallel lines. So if this is 29 degrees right here, then what type of angle pair are these? Alternate interior. So that's 29 degrees also. Does that make sense? This is parallel to this one, so these are alternate interior. Yes? Okay, I don't even know what they're asking me yet, but I'm just taking a minute to look at the picture and think through what I have so that when I do go over here and look, I at least have some idea of what's going on, and I'm not just going to be throwing numbers around. So on the first one, it asks me for the length of line segment NM, right? NM is a midsegment, right? A midsegment is equal to half the length of the third side. So NM is equal to half the length of what? Well, it's half the length of XY, yeah, XY. And then that means that that is half of 10.2. And what's half of 10.2? 5.1. But you got to be able to write that down algebraically because they're not always going to be numbers that you can just take half of. All right, so then XZ, that's what I'm looking for. XZ is not a midsegment, but its midsegment, which is LM, which is 5.6, that is equal to half of that side, which is XZ. So if I actually want XZ, what do I do? Multiply by 2. What's 2 times 5.6? 11.2. Okay, so then NZ, what's the length of NZ? 5.6, because we've already, we labeled that they were congruent, so that one's just 5.6, right? All right, then angle LMN. LMN. Well, I already decided it's congruent to that, so that's 29. YXZ, YXZ is this angle right here. Is this also 29?
Yes.
What kind of angle pair is this? Corresponding. It's 29. Angle XLM. XLM is this angle right here. Got a linear pair or same side interior angles, however you want to do it. So they have to add together to give you 180. So what does this length have to, or what does this angle have to be? 151. Good. All right, so look at the second one. It says, what is the length of the midsegment? Well, first of all, is this a midsegment? Yes, it connects the midpoint. So I can't just take half. The midsegment, which is n plus 8, is equal to half the length of the third side, which is 6n. You see how you set that up algebraically and think through it? Now, go ahead and finish that up while I pass out the homework real quick, and then we'll talk about what the answer is. What does n equal? 4. N equals 4, so the mid-segment is what? Oh, I can't even write. Mid-segment is 12. Good. So the mid-segment, because I got to do 4 plus 8, that is 12. All right, good. Any questions? All right.